We are continuing with the textbook questions. Which of the following represents the correct IUPAC name for the compounds which are concerned? So we need to figure out which of these IUPAC names are right and which one is wrong. So the first one is 2,2-dimethyl pentane and 2-dimethyl pentane. So obviously, if you have a methyl group present two methyl groups, and if they're present at the second position, they are not denoted as 2-dimethyl pentane, but they're denoted as 2,2-dimethyl pentane. If it was in the first carbon, it would have been, wait, yeah, 1,1. Basically, the number should be mentioned twice. If it was in two different positions, obviously we'd mention the numbers, right? So the same thing follows. Next, 2,4,7-trimethyl octane or 2,5,7-trimethyl octane. So based on the first point of difference rule, if you have the substituents, the first point of difference, that is 2 and 2 are the same. So between 4 and 5, 4 is lesser than 5. Because of that, 2,4,7-trimethyl octane is the right one. Next is 2-chloro-4-methyl pentane or 4-chloro-2-methyl pentane. Since both of them are basically the same, same priority, it's given alphabetically. So because of that, this particular compound would be the right one would be 2-chloro-4-methyl pentane, because 2 alphabetically speaking is lesser, and so it's for chloro. Next, but3-wine-1-all or but4-all-1-ine. So there was this entire video we did where if there was a functional group and a double bond or a triple bond, then what the priority would look like. And in that case, the priority for ine is lesser than the functional group. So functional group gets more priority. So but3-wine-1-all is the right one. Draw the formulas to the first 5 members of each homologous series, beginning with the following compounds. So when you have a homologous series, they basically differ with respect to a CH2 group. So except for the first one in this case, so you have CH3, and after that, all of them, you have an extra CH2 attached to it. So these are the 5 homologous or first 5 members of the series. So here also we've increased the number of CH2 groups on one side. So these all form a homologous series. You can do it even on this side alone, but you can't do for both because there would be a difference in properties. Next, it's the same over here. You have an alkene. So we are just adding a CH3 group on this side. Next, give the condensed and bond line structural formulas and identify the functional group present, if any. So basically, condensed formula will just give us the number of atoms and the individual, what are the number of atoms in each attached to each carbon, whereas the bond line formula will give us the basic skeletal structure. So 2,2,4-trimethyl pentane. Honestly speaking, I find bond line formulae easier to draw. So if you do find that easy, you can start it from the bond line formula. Or if you find this also difficult, there is no harm just writing a 5-membered chain that I'm going to embarrassingly do right now. Okay, so we can start with having 5-membered chains. So this is it says trimethyl pentane, right? So it has 5 carbon atoms. So 1, 2, 3, 4. It's a carbon atom. 5. So according to this, it's 2, 2, and the 4th position you have methyl groups. So let's assume we're going from left to right. So this is the first carbon, this is the second, third, fourth, and fifth. So in this carbon atom, in this compound, this carbon and this carbon have methyl groups attached to them. Then you also have the 4th carbon atom having a methyl group attached. So it's basically CH4. Forgive me for such horrible handwriting. Anyways, Then you can just fill in the hydrogens. For example, this carbon atom can have 3 hydrogens. This will have 2. This will have 1. This will have 3. So fill in the hydrogens and you get the expanded structure. Okay. And then you can write the condensed formula from this. So this carbon atom has 3 CH. Oh, I'm sorry. This CH3, not 4. Oops. I am so sorry. So, yeah. Mistakes happen. We accept it. Anyways, so CH3 groups, this carbon has 3 CH3 groups attached to it. So CH3 taken thrice, carbon, this one. And then you have a CH2 because it has 2 carbon atoms, and then a CH, and it has 2 CH3 groups attached to it. So the CH3 and the CH3. So it's your call if you would like to first draw the whole chain and then deduce the condensed formula from there. It's not at all wrong. And then we'll obviously write the bond line formula. So here also 1, 2, 3, 4. So 1, 2, 3, 4, and 5. 5 carbon atoms. 1, 2, 3, 4, 5. So the second carbon atom has 2 methyl groups attached to it, and the fourth carbon atom has 1 methyl group. So you can write it like that. Next one, oh, and we need to figure out if there are any functional groups, but there are no functional groups because they're all methyl groups attached to it. Next to hydroxy, 1, 2, 3, propane tricarboxylic acid. So it's obvious that there are 3 carbon atoms, propane, right? So the 3 carbon atoms are basically attached with acids, COOH groups attached to it. And then you also have a hydroxy group at the second position. So basically, this is our structure. Okay. This is the structure. Or if you'd like to start with the straight chain structure, then let's just start from there. Okay. So carbon, and another carbon. So this is the propane structure. Then propane tricarboxylic acid. So this carbon atom has a COOH. Wow. This carbon atom has a COOH. And this carbon atom also has a COH group attached to it. Not only that, we have a OH group attached to the second position. So this is the compound. And this carbon does not need any more hydrogens. This one, on the other hand, requires 2. So this would be CH2, and this will also be CH2. So this is the basic structure of the chain. But so from there, we will be able to deduce the condensed formula. So COOH, CH2, C. The reason we put brackets, it means that these 2 groups are attached to this carbon atom. And then you have another CH2, COOH. From there, we were able to draw the bond line structure. So if you find this easier, it makes sense for you to start from this kind of open structure and then go from there. So the functional groups are obviously acid. You have an acid here, an acid, and an acid, as well as an hydroxy, which means an alcohol group at the top. Let me just clear it out. The last one is hexane dial. So it is dial, which means there are 2 aldehydic groups, and aldehydic groups cannot be in between, right? They have to be on the ends because they are COH. So at the 2, first we'd be drawing the hexane chain, and then you just have to write the aldehydic groups on the either side. In the next video, we'll be continuing with the textbook exercise.